Good day, grade 12s. Welcome back to another lesson. Grade 12s, in this lesson, we'll basically just be tackling a certain type of question that is usually asked and counts quite a bit, usually about 4 to 5, sometimes 6 marks in the exams. And in this question, we will be tackling combined sequences. So you will find grade 12s at times, you'll be looking at a sequence in the exam or when doing past papers, and you'll see that the sequence actually is neither arithmetic, it's neither geometric, and it's neither quadratic. So, in such a case, most grade 12s would usually just start crying or skip the question. But in this case, I want us to deal with these type of questions so that we're better prepared for the questions and we're prepared for anything that they might ask us in the questions. So here are a few steps I'd like for you guys to write down in your books with regards to how to approach such a question. So combine sequences, grade 12s. And here are the important steps to follow. The first step that you'd follow is to ensure, firstly, you follow all procedures taught in prior lessons and see whether the said sequence matches either arithmetic, matches either quadratic, matches either geometric. Now, step 2, provided the sequence does not tick the boxes for arithmetic, quadratic, or geometric sequences, we follow step 3. We separate the terms, yes, into two sequences of their own. And then we deal with each and every question as an individual sequence. Now, I am going to do a few examples here so that we could see what we mean. Now, the first example, when we actually come and tackle the first example, we can see here, it is written that given below is a combination of sequences of an arithmetic and a geometric pattern. Now, they're being very kind, boys and girls. Usually, they'll just hoy this in your face. They throw it in your face without letting you know that it's a combination, and you would have to then figure out that it is actually a combination. Now, boys and girls, question 1.1. Let me just quickly write the sequence down. So the first thing is, it's given to us, so we don't have to actually go and test whether it's arithmetic or not. Now, from there on, they state to us, 1.1 states, if the pattern continues, write down the next two terms. Now, boys and girls, I said in step 2, if it does not, tick the boxes for the other sequences, therefore it's a combined sequence, right? We can conclude that it's a combined sequence. Then step 3, it says, separate the terms into two sequences of their own. And this is exactly what we're going to do according to step 3. So we could see we have a 3, we have a 6, we have a 12, right? So we're just going to write it down. 3, 6, 12. And then we can also see we have an 8, 5, 2. We also have an 8, 5, 2. Okay, boys and girls, now we've separated the terms into two different sequences, and we deal accordingly, right? Yes. Now, what we're going to do here, we're going to deal accordingly with each and every sequence. So let's first start with the sequence. We could see that they added 3 here, and they added 6 here. But they did tell us that these sequences are arithmetic and geometric. So this is not an arithmetic sequence, so therefore this is geometric. So, and in a geometric sequence, we would describe our general term as, remember, we would describe our general term, so we want to write it somewhere here. So if it's geo, remember, we describe it as T of n is equal to A R n minus 1. If it's arith, it's usually T of n is equal to, okay, there we go. So what we're going to do is, here we could see that it's not arithmetic because we're not subtracting or adding a constant number. There's no common difference. So therefore we can then conclude that it is indeed geometric. So R is equal to T2 over T1. Therefore, 6 over 3 gives me, if we simplify it, it gives us 2 essentially. And if we were to do the same, just to double check, if it is indeed arithmetic, we would say T3 over T2, we would say 12 over 6, and we know that 12 divided by 6 is actually 2. So I'm just quickly going to erase this for now. So therefore, that being said, excuse me, boys and girls, therefore, R is equal to 2. Our A, we look at this as a whole new sequence, and our A is 3. So therefore, T of n is equal to 3 multiplied by 2n minus 1. And we know that the next term would be term 4. This would be term 4. The next term that would follow in this sequence would be term 4. So therefore, T of n is equal to T of 4 is equal to 3, 2, 4 minus 1, which essentially just gives us, T4 is equal to, if we simplify it, 3, which gives us 8. So in the end, it's T4 is equal to 3 times 8, 8, 16, 24, and T4 is equal to 24. Perfect. Now, from there on, we deal with the different part of the sequence. So we've dealt with the arithmetic part. We've dealt with the geometric part, boys and girls. We're now going to deal with the arithmetic part, which is quite straightforward also. So we're going to quickly I'm just quickly going to create a border here. Quickly going to write our arithmetic sequence, and that's 8, 5, 8, 5, and 2. And then we know that this would be T4, because we treat them as new sequences of their own. So here I would see, boys and girls, that we're actually subtracting 3. We're subtracting 3, right? That's our common difference. So essentially, we're subtracting 3 to get to the next term. So what would actually happen is we would have our T of n is equal to A plus n minus 1D. So this would be our D. And our A, boys and girls, would be 8. So T of n is equal to 8 plus n minus 1D, which is negative 3. Therefore, T of n is equal to 8 plus 3 minus 3n. Therefore, T of n is equal to 11 minus 3n. And we're looking for the fourth term because they said they want the other two terms that follow. Therefore, T4 is equal to 11 minus 3 times 4. T4 is equal to, boys and girls, T4 is equal to 4, 8, 12, negative 12. So it's 11 minus 12, and T4 is equal to negative 1. Does it make sense? Remember, we're subtracting 3, so 2 minus 3 was supposed to get you negative 1. Yes, it does make sense. So, boys and girls, ultimately, you'd get a mark for, they did tell you that it's an arithmetic sequence. You get a mark for coming to getting your R and your A. You get a mark for your final answer and your mark for substituting inside. You'd also get your mark here for your final answer, substituting, and so forth. Okay. Good. 6 marks. Barely happens, but it does happen. Question 1.2, boys and girls. Question 1.2. Now, question 1.2 states to us, 1.2 says, determine the 15th and the 16th term of the given sequence. Okay. So, boys and girls, 15 and 16th term. Now the long way would be to go and say 1, 2, 3. We've already got 4. Excuse me. 4. We've already got 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. They want the 15th and 16th term of the given sequence. So they're referring to this sequence, right? Now, let's see what would fall under arithmetic and what would fall under geometric. So remember, we already said that the three, anything after this, like anything with the pattern that coincides with the 3 was geometric, right? So I'm going to quickly color in green anything that would be geometric. So this would be geometric, 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 geometric. Oh, come on. Geometric, 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 and geometric. And anything that would be arithmetic would be in blue. Arithmetic. Okay. Now let's quickly see the 15th term. Let's count 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 is in green. So 15 is what? 15 is geometric. Now, what we do is, for question 2, question 1.2, question 1.2, T15 is in the geometric, would fall under geometric. So what we'd say is T15 is in the geometric part, right? And that being said, we know that we'd use our geometric formula. T of n is equal to A R n minus 1. Now, boys and girls, would we substitute 15 into our geometric formula? No. Why? Because despite it being 15 in the original sequence, it is not 15 in the geometric sequence. So let's see. We said that 15 ends here, right? So this is our 15th term. So let's see what term it would be. 1, 2, 3, 4, 5, 6, 7, 8. So it would be T8 in our geometric term, or sequence, formula. So that would be T8 is equal to, let's just see what our A value here was. It's 3. And we know that our R value was 2. So it would be 8 minus 1. T8 is equal to 2 to the power of 7 times 3. Excuse me. 2 to the power of 7 is equal to 1 multiplied by 3. That's 384. 384. Okay. And this is equal to, in the original sequence, this is equal to T15. Then we go again. They wanted 15 and 16th sequence. Okay. So let's see what is under what the, okay, let's look at the original sequence. Let's see under which sequence, arithmetic or geometric, would the 16th term fall under. Okay. I'm going to use a pink pen now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. It's blue, therefore arithmetic. Okay. And we said that our arithmetic sequence can be described this way. And we said that T of n is equal to, now T of n formula is here, 11 minus 3n. 11 minus 3n. That's our T of n formula simplified. Our T of n formula simplified is, 11 minus 3n. Now, do we substitute in 16 into our T of n formula? No, we do not, because the 16th term represents the position in the original sequence, not in our arithmetic sequence. So what we do is we go back and actually now see, I'm going to use a different color. What position is it in our arithmetic term? So we just focus on blue now. Okay. 1, 2, 3, 4, 5, 6, 7, 8. So it's T8. Okay. So we therefore say T8 is equal to 11 minus 3 multiplied by 8. T8 is equal to 3 times 8 is 24. So 11 minus 24. T8 is equal to 13. No, negative 13. 11 minus 24 is negative 13, yes. Negative 13, which is equal to T16, boys and girls. So you see how you have to think, first separate. After separating, you have to note that given the fact that I, as an individual, was able to break it down into two different sequences, I have to understand that if they tell me the 15th or 16th term or the 74th term in the given sequence, it does not mean necessarily in my formula of the geometric or arithmetic I'll plug in the 74th term or the 16th or the 15th term. Okay. Now I want us to tackle quickly another question, and then from there on you guys can do more examples on your own. Question 1.1 again. Now, boys and girls, question 1.1 states, write down the next two terms in the given sequence. So we see here, it cannot be arithmetic because from 12 to 4, you subtracted 8, and here you subtracted 10. Okay? Does it make sense? No, it doesn't. So we'd follow our procedure. We first follow our procedure. So it does not fit the proper standard of an arithmetic. So arithmetic is out of the picture. Does it fit the proper standard of an geometric? Let's see. 14 over 4 is the same. 14 over 4 is not the same thing as 4 over 2, so it's not arithmetic. Could it be quadratic perhaps? Let's see. We know that with quadratic, the second difference has a common difference. Okay. So from here to here, we must subtracted 8. From here to here, we increased by 10. So nope, it does not actually fall under a quadratic. So we could see that we have two different functions on their own. So let's separate them. 12, so you would be here. Do you see the pattern, guys? Do, skip, do, skip. So do, skip, do, skip, do, skip. So we'd have 12, 14, and 18. Now, would you say that this is an arithmetic sequence? Let's see if I quickly 14, okay, 12, 14, okay, perfect. Would you say it's an arithmetic? Arithmetic increases, right? So here we'd say we increased by 2, and then here we increased by 4. It's not arithmetic. Would you say it's geometric? Remember, geometric, they has to have a proper what's it called again? The common ratio has to be equal. So this is not equal to this. So therefore we could see we have a quadratic on our hands, boys and girls, because from here to here I'm adding 2. So let's quickly get it into our general form. Remember the general form for a quadratic, boys and girls? an squared plus bn plus c to get our formula, remember, 2a is always equal to the common difference. So 2a is equal to 2, a is equal to 1. Then we have 3a plus b is always equal to the first difference of the two original consecutive terms. So this. So 3a plus b is equal to 2. And 3, we know we already have a, we substitute a inside, plus b is equal to 2. B is equal to 2 minus 3, which is negative 1. Now, a plus b plus c, boys and girls, is equal to the first term. And the first term is equal to 12. Therefore, 1 plus negative 1 plus c is equal to 12. Therefore, c is equal to 12 because these two cancel each other out. Therefore, our t of n is equal to 1n squared minus 1n plus 12 for the quadratic. And then from there on for the, excuse me, let me just quickly put a barrier here. And then for the other one, I'm going to quickly color it in purple. I'm just quickly going to circle. Okay, for the other sequence, yeah, we have 4, 7, and 10, right? Now, boys and girls, we have 4, 7, and 10. And given these sequences, let's see what we have here. Now, from 4 to 7, we added 3. And from 7 to 10, we added 3. So, therefore, this is arithmetic. And we follow the formula T of n is equal to a plus n minus 1d to get the general form. Now, T of n is equal to a. A is the first term, which is 4 plus n minus 1 multiplied by 3. And we can just simplify it further by saying that 4 plus 3n minus 3. Therefore, T of n is equal to 3n plus 1. Okay? Now, they want the next two terms, okay? The next two terms. Now, now they want the next two terms. Now, this is where we do what I did. Where it gets a bit funny, but makes sense. They want the next two terms. So we see that 12 is T1. This is T2. This is T3. This is T4. This is T5. This is T6. And we're looking for T7. And we're looking for T8. Because they want the next two terms. Okay? Now let's look at this. In order for us to get T7, let's see under which sequence type does T7 fall. Okay, let's see 12. 12 is arithmetic. We said skip. 14 is arithmetic. Excuse me. Just ignore what I just said now. Okay. 12 is quadratic. We said skip. 14 is quadratic. We said skip. 18 is quadratic. We said skip. So therefore, 7 is quadratic. Now, and then from there on, let's quickly deal with the other ones. Now, the open gaps. 4 is arithmetic. 7 is arithmetic. 10 is arithmetic. And T8 is arithmetic. And in both, excuse me, boys and girls. Yes. And in both of these separate sequence types, when looking for the next two terms, we are going to not say T7, we're not going to say T8, but rather we're going to say T4 for quadratic, T4 for arithmetic in order to get the next two terms. Okay, let's first deal with the T7, and we said that T7 is what? T7 falls under the quadratic one. And we said that T7 in this case is not 7, but we would put it as a 4 because T7 comes after the 18. Okay? So we would put a 4 squared minus 1 times 4 plus 12, and T4 is equal to 4 squared is 16 minus 4 plus 12, and we said that 12 plus 12 is 24. Excuse me. So 24. Therefore, T7 is 24 in the OG or the original sequence. Right. So this, boys and girls, would be 24. Then when we move on to T8, T8 is, as we said, falls under the arithmetic part, and T8 would be here. So in the arithmetic sequence, it would be 4. So therefore we say T4 is equal to 3 times 4 plus 1. T4 is equal to 4, 8, 12. 12 plus 1, and T4 is equal to 13. There we go, boys and girls. And therefore, T8 in OG sequence is 13. Now, boys and girls, I want us to deal with the calculating the value of the 50th term. Okay. Now, I want us to see, they say calculate the value of the 50th term in the sequence. Now, I don't want you to be going on, off, on, off, on, off. We already see a pattern here. Let's just get to 10, okay? Just follow my lead. So we know that after this, in the original sequence, there would be gaps. And we know that after T8, we'd have a T9, we'd have a T10. Okay? Right. They say in 1.2, calculate the value of the 50th term of the sequence. Remember, when they say of the sequence, they will always refer to the original sequence that was given to you, boys and girls, not the one that where you were able to decipher that, there's actually a combination of sequences in this case. Now, boys and girls, the 50th sequence. Now, we'd see that, I just want us to take our red pen and our purple pen. We'd see that T9 is purple. We'd see that T10 is red. And then the pattern continues and continues and continues, right? Yes. So therefore, we know that T50 would be the value of a red. And we said that the red, boys and girls, is an arithmetic, right? Is an arithmetic. I want us to quickly go here. 1.2 T50 arithmetic falls under the arithmetic sequence we found. But now, what number would we be putting into our arithmetic sequence? Would we be putting in 50? No, because 50 is not the position in the sequence we were able to find. 50 is the position in the original sequence. Now, what we're going to do is we're going to say, we can see that there's 5 in the number of 10, in this row of 10, we can see that there's 5 arithmetic, 5 quadratic. So therefore, and let's say we'd have 10 here. We'd have 10. Imagine we have numbers going 1 till 10, 11, till 20, 21, till 30, 31, till 40, 41, till 50. We would always have 5 arithmetic, 5 arithmetic, 5 arithmetic, 5 arithmetic, 5 arithmetic. So therefore, the position would be position number 25 in the arithmetic sequence. I hope that makes sense, boys and girls. And I apologize again if I do seem to be a bit, I guess, teaching, if I do happen to be teaching you guys like I'm a bit, like you guys are a bit slow or something. But I just want you guys to see how I think about things, and I want to teach you guys how to reason and approach these questions properly, okay? So now we said that it's T50 in the original sequence would fall under the category of an arithmetic. So therefore, T of n is equal to, we said 3n, if I'm not mistaken, plus 1. And we said that we would use T25 instead of T50 because in a line of 10, there would always be 5 quadratic and 5 arithmetic. And I explained here. So if there's 5 in a line of 10, there's 5, 5, 5, 5, 5. So therefore 5, 10, 15, 20, 25. I hope you understand, boys and girls. And T25, we would have 75 plus 1, and T25 would give us 76, the value of 76. And in this question, it would be a good 3 marks because you would also have to think, boys and girls. You would also have to think. Okay. I think we should move on to question 1.3. And they say, write down the value of the 131st term of the sequence. Now, remember 131st. What was first always? First was a quadratic sequence. So now we're going to be looking at a quadratic case. Now question 1.3. We know that we'll be dealing with our quadratic sequence. And I apologize for writing a bit ugly now. So the formula that we got was n squared minus 1n plus 12. So T of n is equal to, T of n is equal to n squared minus 1n plus 12. Just make sure, double check, perfect. Now we said that it's now n's, write down the value of the 131st term, okay? Now, boys and girls, I did just speak to you guys about this. Are we going to put in 131 here? And for the love of God, if you do say yes, I'm going to go sleep now at this point in time, go play a little bit around and then come back when your senses are proper. Okay, that was just a joke. Don't kill yourselves. But what I'm saying is, boys and girls, no. We found out that 131st term is not the position in the sequences we were able to find ourselves. But the 131st position is the position where in the original sequence. Okay. So now, remember I said 1 to 10 to 20, 11 to 20, and then I said 21 to 30, 31 to 40, and 41 to 50. And I said that if we're to look at the sequence in in lines of 10, we would always have 5 arithmetic, 5 quadratic, right? Now they say the 131st term. So we have to go until 131st. 131, I mean. So we'd have 60 here. Excuse me, let me just quickly get this right, boys and girls. Apologies. We would have 60, 70, 80, 90, 100, 110, 120, 130, and 140. But before this, we'd have 131, and so forth. But yeah, the main numbers that matter are here. So now, we said that in a line of 10, we would always have 5. So we would have 5 here, 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 and so forth, all the way up to here, up to 130, because they wanted 131, okay? So we'd have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 65 plus 1, because they said 131, and we know that the first term is quadratic. So 61. We know 61. Let's check again. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. Okay, let me just quickly make sure. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 1. So it would be 166. Ah, man, I mean not 166, but 66. 66 would be the position, would be the N. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65 plus 1 year. 66. Apologies, you're going to hear a dog bark, but you're going to hear a dog bark in just a second. But yeah, 131, we would get 66. Another way would just be saying 131 divided by 2. And remember, or 130 divided by 2 plus 1, because we are now starting in the first, and we said quadratic is the first. So that would be t of 66 is equal to 66 squared minus 1, 66 plus 12, and t66 is equal to 66 squared. Let's just get that out of the way. 66 squared, that would be 4,356. 4,356 minus 66 plus 12. T66 is equal to 4356 minus 66 plus 12, which is 4302. I hope I made sense, grade 12s. I am going to end it here, and I'll provide you guys with more examples because it's getting a bit rowdy, and we actually are done with our terms. The main thing, follow the steps, follow the procedure I took, and you should be fine. Thank you very much, grade 12. Subscribe, please, and yeah, all the best of your studies. Cheers.